So then also welcome from my side to everybody. We have a short introduction slide deck that we want to show. So today's meeting is about a summary of a hackathon that we had together with the Metal Stack folks. So a joint hackathon from the Gardener and Metal Stack teams. And it happened in the beginning of November in a location in Austria. It was already planned for 2019, but then skipped because of the pandemic situation. In total, we have been 10 attendees, and we worked on more or less 3 bigger topics and a couple of smaller topics that we called fast tracks, small improvements that were not taking too much time. In total, it was a good mix of topics related to Gardener, but also topics related to Metal Stack mainly. The location was in the Tyrolean Mountains. We had also opportunity to hike. Here is a few pictures just to show you the general setting. So in total, it was really great and productive environment. So eventually we came up with these topics that we would like to present here. The first topic was a larger one that we worked on, which is to make the Kubernetes version configurable per worker pool for shoot clusters. In today's or earlier, it was only possible to have one version for all the pools. Then the second topic is a POC for Kubernetes control planes as a service. So basically shoot clusters without worker nodes. Then we have worked on a topic that we actually wanted to work on since very long, but never had the capacity and so on. It is about a local provider extension to fully run Gardener with seed and shoot clusters on your local machine without any infrastructure or cloud providers involved. And then a few smaller topics, hibernation support for Metal Stack, some improvements for the mini lab of Metal Stack. And we started to look into some custom etcd encryption configuration. Okay, so with this, I would like to start with the first topic and give a short demo to it. It is the dedicated kubeproxy daemon sets and Kubernetes version pool. So let me switch to the terminal. I have already pre-created a cluster that I call demo. And this cluster has these 2 worker pools. The first pool is called pool 1, and the second pool is called pool 2. They both have min and max set to 1. So when I look into the shoot cluster itself, then I see 2 nodes here, one from the first pool and one from the second pool. And towards the goal of having dedicated Kubernetes versions per pool, we first had to make first had to work on a prerequisite, which is to have dedicated kubeproxy daemon sets per worker pool. Because earlier we only had one kubeproxy daemon set, which was rolled out to all the worker nodes. But this approach will no longer work when the Kubernetes versions are different per worker pool, because then also the kubeproxy versions have to match. So what we have now, when I look into the kube system namespace and list the daemon sets, you see we have these 2 dedicated daemon sets. The first one is for pool 1, version 1.18, same like the kubelet version, and for pool 2 as well. And then there's also this one. This is the old daemon set that I mentioned. This is just here for the migration, basically from the old to the new daemon sets. It will eventually be removed. So it will stay here with 0 pods after the change has rolled out, and then eventually in the future Gardener version fully be removed. Okay, so what I would like to do is I would like to change my shoot and change too many versions, the Kubernetes version from 1.18.0 to 1.18.4. So this is now reconciling in the background. And here I would like to start short watch command. Oh. Both are broken. So you see I list or I read the version here. The server, API server is still on 1.18. It's now in the progress of being updated. So it should soon be 1.18.4. You can check the nodes. So the kubelet is, of course, also still 1.18. It will be updated later then in the progress. And for the daemon sets, we also still have our true that we already saw. Here you already see it's flipping from the new version to the old version because now the rolling update of the API server is happening. So as soon as the old API server pod is removed, it should stay consistently with 1.18.4. Then the next thing that will happen is that we have or will create new daemon sets for the 1.18.4 version. That first will be with 0 replicas, and they will wait until the kubelet itself has been updated. So only when the kubelet here restarts with a new Kubernetes version, then also the kubeproxy daemon sets will be rolled out. Okay, so it's happening just now. You can see the daemon sets were created with 0 replicas. It will now take a few seconds until the kubelets restart, and then we should see the new kubeproxy daemon sets being rolled out. Yeah, and this is also something that actually, I would say, was a bug before, because earlier, before we had worked on this, we all have already updated the single kubeproxy daemon set, and then it was already rolled out before the kubelet itself was restarted in some occasions. And this is more or less violating the official Kubernetes versioning scheme. So it was probably just working by accident, but now it's working as it should be, as required by the Kubernetes control plane and kubelet. Okay, so I hope you could see it while it was happening. Now the kubelets got updated. The old kubeproxy is terminating. The new one is up and running. All good. The old daemon sets will stay here, scale down to 0 until the next shoot reconciliation happens, and then they will be garbage collected. All right, this was the first feature we worked on, and now the actual feature that we would like to achieve was to have the dedicated Kubernetes versions per worker pool. So I go again to the shoot spec and change this is here the control plane version, or the Kubernetes version from 1.18.4 to 1.19.0. Then I go down to my worker pools, and this is now the new field that we have introduced. Here there's also a Kubernetes section, and I can now set the pool 1 also to 1.19, just like the control plane. If I just omit this, then this will also happen by default, but I can make it explicit. And for the pool 2, I could, for example, just keep it with 1.18.4. Okay, so again, the shoot is being reconciled. We have to wait a few seconds until the Kube API server first got rolled out to 1.19 now. And then we should see one new daemon set popping up here for the pool 1, which we have also updated to 1.19. And the pool 2 should just be kept with 1.18.4. So these two daemon sets here will be garbage collected as said. And because this is now a minor Kubernetes version update, the machines will be exchanged in a rolling update fashion as well. So earlier we have performed a patch version update there. The kubelet just restarted on the existing machine, but now we have a minor version update and the nodes will be rolled out. So while this is happening, we could check in the seed cluster. This is now the top pane here, the pods. You see here's our new Kube API server now up and running. This is the old one. That's why it's still flipping, but this is probably soon being terminated. And then we should see in a few seconds here the old pool 1 machine being waiting until the new machine got created and then being terminated. And this is happening now. A new machine for the new 1.19 version is being created. It takes in on this AWS roughly 2 minutes or so until it joins. Okay, I would say while we wait, the current, I can give a current status update. So the change is merged in Gardener. It is behind a feature gate. So without the feature gate being activated, this Kubernetes version cannot be changed in the worker pools. And what is still open is that the provider extensions need to be, first of all, re-vendored to Gardener to get the newest extension library version. And then for those that use CSI and have some CSI migrations in place, which is the case for at least AWS, Azure, GCP, and OpenStack, they also need to be adapted such that they also can cater with this Kubernetes version per worker pool override. But this is still open. We will do it and eventually then promote the feature gate in the future to beta and GA. But if you want to try it out, you can already do it, but you have to make sure that you update your provider extension asset so that it understands these changes. Okay, you can see the new node has joined with 119. The kube proxy here was scaled up and the old one is now deleted. I think with this, I will stop and hand over to Tim for the next topic.
All right, so I'm going to present the next topic, the next hack, so to say, which is about workerless shoot. So as you know, if you create a shoot in Gardener, you will basically get a fully fledged Kubernetes cluster, including the control plane running on the seed cluster and the worker nodes that join this cluster. Our idea was to experiment with a shoot without worker nodes. So you could also call this control plane as a service, right? Because only the control plane would be left. So in order to show you what this means, I have a shoot manifest right here. This is how it usually looks like, including the stuff that is commented out. You specify some provider, cloud profile, region, whatnot, some worker pools, everything that is already known. But our idea was basically to drop all of this stuff that is right here commented out, like the worker pools and so on, infrastructure config. And now that we don't create worker nodes, don't create VPC and so on. Also, there is no requirement for a secret binding anymore, which usually just contains the infrastructure credentials. So this is optional in this mode. And as you see, the shoot specification is much slimmer now, but you can still benefit from all the other features that Gardener already delivers, like the hibernation feature to scale down the control plane when it's not needed. For example, for development clusters on the weekend, you can use the fully automated Kubernetes version, upgrades, maintenance, and so on and so forth. In order to demo what this now looks in practice is I have already created a shoot in my dev setup, which is called workerless. And as you see, it's already created successfully. And in this pane, you see the shoot control plane namespace in the seed cluster. And as you see, it contains all the components that we would expect in a Kubernetes control plane, like etcd, API server, but also controller manager, but obviously no scheduler, because if there are no nodes, we don't need to schedule anything. Some other components as well. And if we now look into the shoot cluster, we basically see that it doesn't have any nodes, right? It also has no pods. but it has the usual namespaces. You can do all the stuff that you want with it. You can create, for example, config maps. I don't know, whatever you want to do. So you get the full API machinery of Kubernetes, basically, including RBAC, extensibility, like webhooks, CRDs, everything that Gardener already delivers with the control plane, like monitoring, logging, and some other features. So yeah, this is basically a fully fledged control plane as a service if you want. During our hackathon, we basically experimented with this and you saw the results of it now. This is basically a POC. It was not implemented properly till the end, but we see some great potential in it, like, for example, for local development, where it might actually not be needed to have worker nodes if you want to do a small change to the Gardener components, and you could already verify it without creating any worker nodes on a real infrastructure. There might be other creative use cases as well, which leverage the Kubernetes API machinery. So if you know this virtual garden concept, this is very similar actually, because also we use it also internally to basically have a data container for all the Gardener API resources, which are basically stored in a virtual cluster, as we call it, which is basically a fancy term for a cluster without a worker node. So it doesn't run anything, but it just hosts the Kubernetes resources. So as says, this is currently just a POC, I would say, and we want to open a Gardener enhancement proposal in the following weeks to discuss how this could be implemented properly and how we want to approach it. And that's already the demo for this topic. Okay, so hold on tight. This one's going to be exciting. This next topic is about the local provider, as we called it. So right now, if you want to get started with developing Gardener or even trying it out, you always need to have real infrastructure, meaning you need at least one public Kubernetes cluster. You could use GKE, for example. And you also need access to an infrastructure account, meaning you need credentials for it and so on to create your first clusters in it. This is obviously quite a big hassle for newcomers for trying out Gardener. This is also a burden for new contributors, because not everyone can simply access some infrastructure credentials. And it is also very costly to always develop with real infrastructure. Also, this is limiting us in terms of fast and cheap end-to-end tests, because we currently always require real infrastructure, which obviously takes quite some time to create and manage. So what we have worked on is to make it possible to do everything on your local machine, like I'm doing right here. The only thing required is a local cluster, for example, we have some new make target, which basically creates a kind cluster with the necessary config. So this is running in my Docker for Mac installation, just giving me a single node cluster for now. So once I have created this could be also K3D or Minikube, by the way, doesn't matter, just any local cluster, which is lightweight enough to run on your machine. Then I can do Gardener up. And what this does is it bootstraps a completely fully fledged Gardener installation on this kind cluster. For this, we use Scaffold, which takes care about building the necessary Docker images, pushing them into the cluster. If it runs locally, it doesn't even need access to a container registry. It can just load it into the cluster directly. And then it uses our Helm charts for bootstrapping all the components. So right now we are building the images. This should be pretty fast because I have done it before and it will be able to leverage the cache. But as soon as that is done, it will load the images into my kind cluster and bootstrap for, at first, the Gardener control plane components, which we should see in this pane right here. Okay, there are quite some components to build, obviously, but it should be finished in a second. Okay, there we go. Images are built. Now we already see an etcd pod, which is required to store all the Gardener API server resources. So we bootstrap this as well. And now once the images are loaded into the cluster, we should see the Gardener control plane components right here. Okay, there we go. We see Gardener API server, controller manager, and scheduler. It will take a few seconds for them to get ready, but once that is done, we should see that the Gardener resources are available right here. Okay, now they are available, but there are just no resources yet, but they will be created in a second. Okay, there we go. We now have a local a project called local, which we can use for creating shoots later on. We also created Cloud Profile and some other resources as well in the background, which will be necessary for creating the first shoot later on. So right now it is loading images for Gardenlet and other seed components into the cluster. And in a second, we see the Gardenlet. Okay, it's already here. And now this should bootstrap the seed cluster. It registers itself against the Gardener control plane as a seed. And now this is available. It's not ready yet, but it will get ready in a few moments. So as you see, the Gardenlet is right now bootstrapping all the seed components in order to make this cluster ready to host some control planes. The last step that we do here is to deploy our new extension, which is called Provider Local, which will be later on responsible for creating all the usual extension resources like infrastructure, worker, and so on. But as we want to be completely local, it doesn't talk to any cloud provider as usual. It just basically sets them to ready and doesn't do any work except for the worker resource, where we basically create worker nodes in pods. to put it in simple terms. So as we want to look at some other topics as well, I will end my demonstration with creating a shoot cluster. If we have time later on, we might take another look, but you can imagine that this will be created successfully and entirely on my local machine. So this is quite a game changer for us, I would say. And we wanted to have this for years, basically. We also want to use it in end-to-end tests to verify our pull requests. So we are currently in the last steps of finalizing this to make it ready for everyday use case. You are also welcome to check out this Gardener issue, which tracks the open points and also links to the branch where the development is still happening. So if you want to check it out already, be aware it's not documented and still under development, but feel free to take a look and try it out. We hope to improve this even further in the future to make it also the de facto local development setup and to ease development quite significantly. And with that, I'm handing over to the next demo.
All right, I guess that should be me, right? And this is Garrett speaking. Let me try to share my screen. This one would be great. All right. Can you see it?
Yes. Yes.
Okay, great. Okay, there's a weird overlay here. Doesn't matter. Okay, I have a rather small one to show. This one is about shoot hibernation for Metal Stack. And before this pull request, the shoot hibernation for Metal Stack was not working. There were deployments stuck in the seed shoot namespace, for instance, and also the shoot reconciliation failed when enabling the hibernation feature. And yeah, this is actually Tim's first pull request to a Metal Stack project, so yay, already worth it. And this was also part of a fast track that we had. So as soon as we hit some topics where we saw that we could not parallelize with our resources that we had at the hackathon anymore, then we were splitting up and going into these fast tracks. And this is really just centered around this one pull request. Yeah, and two things that needed to be implemented here. So the first thing was to thoroughly scale down the deployment replicas that we deploy through the Gardener extension provider Metal. And the second part was to skip several requests that were made in the reconciliation flow to the shoot API server in this Gardener extension provider Metal. And let me now show you that this one works. I have a shoot in our Metal Stack environment here. So here we can now enable the hibernation feature. The moment you can see that we have two machines in this cluster. The first one is a firewall, which is a Metal Stack specific infrastructure component. So every of our Kubernetes cluster has an own dedicated firewall in front of it, which you can also control through custom resource definitions in the cluster. And then there's also one worker node. And this one looks kind of familiar to the kubectl Gardener shoot output. Okay, so now it starts the reconciliation, and we'll now see that it first throws the worker node away, I think. So this one should soon disappear. Also already starts to scale down some of the components here. So this Metal Stack specific things. This is the shoot namespace in the seed cluster, by the way. Already stopped some components. Now the worker node is also gone. And now it's already at 92%. And I think there's now a threshold or a grace period or something by the Gardener resource manager. I'm not 100% sure, but for some reason it takes a little time now until it goes to 100%. Another thing that you can also see is that the firewall is still running because, as I said, it's an infrastructure component and not a control plane component. And yeah, this hibernation feature was actually not so important for metal stack users in the past because our users often rely on local storage very heavily, and you actually don't want to throw your worker nodes away because you have like data written to the disks of the nodes, and then you lose the data, and in most of the cases you don't want it. But lately we launched this NVMe over TCP storage in our landscapes, where we can offer real cloud storage to these physical machines. And yeah, maybe this will then become a more interesting feature for users of the metal stack in our landscapes. And also we have a more exotic use case where people just want a managed firewall, and then they can create a shoot cluster where they can configure the firewall through the custom resources of the cluster, and then they can hibernate it, and the firewall will still do the job. So you don't need the worker nodes and you don't need the API server, but the firewall can still route traffic and stuff like that to stuff that's behind the firewall. So we have some use cases where this is also like nice opportunity for users, and this also goes hand in hand with the headless or control plane as a service track that we did. Yeah. Okay, so for some reason it does not finish right now. I think it takes 5 minutes or something, but then it goes to 100%. I don't know why, but that's actually it. Everything I wanted to show, and I guess I want to hand over to Grigory for the next one. Grigory?
Yeah. So I'm sharing my screen.
Okay.
Okay, so I hope my screen is visible. Is it?
Yes.
Yes.
Okay, great. So a little bit of context. Minilab is basically a testing environment for metal stack. We use it for integration tests, and it can be used by user for local testing of metal stack. So previous version was running on virtual machines, so both switches and machine VMs, and it basically there was a few problems related to VMs. First of all, it's the setup. It required quite a lot of dependencies and was error prone. Second part is that, of course, being VMs, it was quite intensive on resource usage. And the third problem was quite slow startup of VMs. So we, in our new version, tried to use a project called Container Lab. So basically, the idea behind it is it allows to run network operating systems like Cumulus, which we are actually using in containers. So it would ideally solve all these problems for us. Yeah. So specifically at Hackathon, we addressed one small problem regarding running VMs. We still needed the VMs because so here you're gonna see a topology file. So the Container Lab, it allows us to run switch OS in containers. So you see we run two switches. But regarding VMs, we still basically needed to run VMs. But we were planning to do that in containers so that all dependencies are managed by us and installed in container and not by a user. So it would be a less error-prone process. So specifically what we addressed in Hackathon is we are now running very minimal VMs, kind of using Kemu. Here is a script for that. And yeah, I'm going to show you right now how it is. So first of all, I still unable to show a full demo because we are quite time limited, because the startup is still quite slow. The VM part, the container part and VM part, it's actually starting within a minute, but then the other setup, which is handled by Ansible, is it could take some time, let's say. So I'm gonna show you the result. So first of all, we see that, we see that switches are running, and switches are actually running in Firecracker VMs, which are managed by Ignite runtime. So basically, we are running in containers. And we see machines. So machines, we have two machines, but with configuration that can be, so you can set up 3 machines. It required for our cluster API testing. So these machines were still running in a single container. Yeah, so here it is. These are Kemu machines, and you can actually try to install OSs there. So, for example, like that. Yeah, so we have kind of predefined 2 makefile directives. One that installs the actual machine that you can later use to deploy Kubernetes node on, and one that you can install firewall in front of machines. Yeah. So we see that they are actually installing it now. It also will take some time, I guess. Yeah. So while we're waiting, yeah. So you can actually already try it out. Go to Minilab repository, download it, try to play with it, and you can also try cluster API provider on it, so it's actually running and working them. And yeah, I guess that's it.
And what's, I guess, sorry?
Yeah.
I guess what's nice about this is that these preparations really prepare for also having MetalStack and Gardener running locally. So the other stuff that Tim, for instance, was working on, where you can easily deploy Gardener into the kind cluster, it can run in parallel to this mini lab, and then you could have MetalStack with Gardener on top on your local machine, which is kind of a nice development thing, but also kind of nice to show to other people when it works. So you don't need this full-blown physical hardware racks in order to make this all happen. You can also show it locally. And this was the preparation for that, and it's nice, I guess.
Yep. Yes, so I guess it's it. Yep. So almost all machines are ready.
Yeah, so what's also going on in the background, why we need these virtual machines, is that they are PXE booting. So you need a BIOS and stuff like this. So we cannot get rid of virtualization completely. We need these BIOS things to run in order to make our discovery image start and stuff like that.
Okay, then I think there's one last topic, quite short one. Here we cannot show a demo, unfortunately, but let me show you what it is about. So this was more or less done or started because we had some time left and wanted to work on a topic that apparently is small enough to be finished. It is about this issue here in Gardner for 606 and the support for end users to provide additional information to us or to Gardner, which Kubernetes resources should be encrypted in etcd. So this description says so far only the secrets are encrypted by default. And if there is a user that has a custom resource, for example, or whatever use case you can imagine, let's say a custom resource, and there are also critical information or credentials in the spec, then this customer usually also wants this resource to be encrypted in etcd. So this is all about the ticket. And when reading it, it sounds like a pretty standard task, some configuration on the Kubernetes control plane, where we just want to pass some information from the chute, let's say the name of the custom resource, and then reconfigure the API server with it and be done. So that's why we thought, okay, let's try this out. We didn't finish it, as said, but let me first show you this one. So this is a chute example. And the idea how this would look like is that there is the Kubernetes section here. And then there is the Kube API server section where you already can configure quite some settings. And the idea was to introduce this one, a new setting called encryption config, where the end user, as said, can just enlist additional resources, like whatever, config maps, but also custom resources. And the secrets would still be encrypted by default like it is today. And this would also not be able to be disabled. Okay, so this we started, and after some time extending the API, writing the validation and so on, we came to the part where we had to compute the configuration for the API server. And there we then face the following challenge that is also currently already implemented for secrets, but would be needed to be extended. And this is that in order to make the encryption effective in etcd, you have to rewrite, or you have to make the Kube API server rewrite the content in etcd. So if you just add something here, restart the API server and do nothing, then also nothing will happen until, let's say, the custom resources is updated again and hence rewritten in the etcd. For secrets, this is implemented already in Gardner. So when you update a cluster to the Kubernetes version that supports secret encryption, then Gardner already sends empty patches and rewrites all these secrets, or makes the Kube API server rewrite all the secrets basically. But similar behavior would be needed to be implemented for whatever the user specified here. And I think at this point, the implementation required first kind of prefactoring of the existing etcd encryption handling. And then we didn't have enough time to finish on this. But we started it, and there is some work in progress branch here, Tim's fork, enhancements, encrypted resources. And basically this rewriting part is missing. The API is there, the validation is there.
Yeah, maybe already one answer to what's the relationship to MetalStack for the Kubernetes version per node. So one thing that we realized when we were browsing or searching for topics for the hackathon was that we have actually a lot of user complaints and concerns in common. And yeah, one thing was that we needed this graceful update procedure because our users, as I already pointed out, often rely on local storage, and you have these drain timeouts when you would do this worker role thing, but it's better if you can just define on your own when a worker node gets erased and added when you update a version as well. So this was very interesting for us as well.
Hi, this is Vasu. Thank you, everyone. I mean, as you might think, we should do hackathons actually every week. This is really great. I love all the features that you came up with, and I think I need some help trying out the mini lab at some point. Thank you very much.
Yeah, we were also very happy at MetalStack that the SAP colleagues joined, because we knew that working with these guys is just a lot of fun, because we had this experience already in Walldorf 2 years ago when we started with MetalStack on the Gardener project, or other way around, I don't know. But yeah, it was just a pleasant experience, and I think we don't have this opportunity so often to do these kind of things, and yeah, it was a pleasure to work with you. So thanks for this week, actually. It was great.
For the entirely local setup, how did you guys work around the requirement of having the DNS provider secret in there?
We have tried 2 different approaches actually, and they depend on how you want to run the local extension. So I just showed how it would look like if it was running in the kind cluster. And for this case, we basically create a dedicated core DNS in the kind cluster and simply point the relevant components to use this core DNS, and it is able to resolve the API server DNS records to point to the Istio ingress gateway. And by this, you don't actually need a proper DNS secret. If you want to run the extension on your machine directly, so basically go run style, then it will manipulate your etc hosts file to publish the API server records. Yeah, this is kind of a hack. Actually, we would like to rather use the core DNS that is running in the cluster also on the host, but for some reason we failed to configure it properly that the usual DNS lookups still work while also the in-cluster lookups work. Yeah, but currently it is using this core DNS in the cluster for implementing DNS.
That's a great help. Thanks.
So the next step with this local setup is to add the mini lab of the metal stack, I guess, and then you could also create a seed on AWS or on hyperscalers, right? And that would be also an alternative path for taking the local setup to a more real world experience.
This could be done. So you have. Oh, what did you just say? The seed on AWS or the shoot on AWS?
Yeah, the shoot, I guess. Yeah, even the shoot would be possible, right?
So what I have experimented with last year was to have a local seed cluster, also based on kind, and then create the worker nodes on AWS or whatever real infrastructure, and then let them connect back to my Kube API server running on kind via Tailscale. So there's also even some POC implementation, like a Garden extension for it. Yeah, so this could be done the other way around.
But with the reverse VPN, you do you still need that? Coming back to your
yeah, sure. The kubelets still need to communicate with the Kube API server, which is on my machine.
Oh, yeah.
So when they run on AWS, they need to get to my machine somehow.
Yeah.
But yeah,
Anyhow, that feature would be also great, not only for developers, but then to kind of bootstrap the local setup, do a control plane migration later on, and then have the gardener on a proper infrastructure.
Yeah. I think there are many nice and creative ideas once we have this.
Next hackathon.
We now, maybe we first focus now on documentation as the next step, clean it up a bit so that it can be used, and then it's also no longer in the special branch but in the master branch eventually. And then we want to connect integration tests for it, and then we can see next year there are quite some limitations and let's say things that we could do if we want that are enlisted in this issue that Tim showed. So if we want and have a special need, we can continue on them.
Cool.
But our first goal is to get it in and have the tests running. It would already be helpful.
Okay, anyone else? If not, then also thank you from my side, and see you next time.
Thank you all for joining.